How to solve rational functions. Let's start by solving something simpler. For graphing, we need to confirm it to a different form. Let's divide 4x plus 3 by x plus 2. For that, we need long division. Do so by dividing 4x by x, adding it to the top number, and then multiplying 4 back into x plus 2. We are left with the original 4x plus 3 and the resulting 4x plus 8. Subtract 4x plus 3 by 4x plus 8 and we are left with a remainder of minus 5. Since x plus 2 cannot go into minus 5, we must write it as minus 5 over x plus 2. Now that we have 4x plus 5 over x plus 2, we can begin thinking about graphing. What do we do with this? To graph, we need to find some important data. This is a rational function, a result of one function being divided by another. Almost all rational functions are distinguished by two lines, one vertical, one horizontal, that the function never passes or touches. We can find these. Let's begin by finding out what x cannot be. We know that any number cannot be divided by 0, and adding a number divided by 0 to a real number would also be impossible. So what satisfies x plus 2 equals 0? X equals negative 2. So we know the x value cannot be equal to negative 2. Envision this by drawing a line down negative 2. This line is called an asymptote, and essentially represents what the lines of our function cannot touch. As x gets closer to negative 2, our denominator becomes closer to 0. When we divide a number by smaller and smaller fractions, it comes closer and closer to infinity. What about the y value? If we look at our equation, we have 4x minus 5 over x plus 2. This is a little harder to think of, but we can use the idea of an altered function to clarify it. For this example, think of the base function f of x as 1 over x. G of x equals af k x minus d plus c. In our case, a would be negative 5, f would be 1 over x, k would be 1, d would be minus 2, and c would be 4x. However, this is not exactly the same as a regular altered function formula, which has a specific base function. We technically have two functions within our formula, both 4x and 1 over x. This means that the exact idea of an altered function doesn't work, as we don't know which function was the original. However, the same principles still apply. Y can never touch the line 4x, because to do so, 5 over x plus 2 must equal 0. However, y gets closer and closer to 4x as x approaches infinity, as 5 gets divided by larger and larger numbers and gets closer to 0. Instead of thinking of c and d as shifting by a certain point up or down, left or right, treat it as plotting a line. As you can see, our d value, or vertical line placement, is also the vertical asymptote, or the line x equals minus 2. Therefore, our c value would be the oblique line placement, and the oblique asymptote along the line y equals 4x. Now that we understand the idea of plotting asymptotes using long division, and the general look of a rational function, we have all the tools to solve our function, x squared over 3 minus x. First, let's reorganize this. Change 3 minus x to minus x plus 3 to make x squared minus x plus 3. Now we can do our long division. We are left with minus x minus 3 plus 9 over minus x plus 3, or 9 over minus x plus 3 minus x minus 3. Now let's find our asymptotes. Let's refer back to our original function model. F of x equals 1 over x, g of x equals a, k, x minus d plus c. Here, a equals 9, k equals minus 1, d equals 3, c equals minus x minus 3. It may look a little confusing, all written out, but if you input these numbers, they will correspond back to our original function. Let's first find our vertical asymptote. What satisfies the equation 3 minus x equals 0? 3 equals x. This also matches our d value, so we know the line x equals 3 is our vertical asymptote. As for our horizontal asymptote, our c value is equal to minus x minus 3, So we can simply state the line y equals minus x minus 3 is our oblique asymptote. But how do we graph this? Since we have our asymptote guidelines, we know that our function will approach but cannot touch the lines x equals 3 and y equals minus x minus 3. And we know that as they approach those lines, their corresponding values will approach infinity. Let's do 2 points on either side and fill in the blanks with our knowledge on asymptotes. And with that, we have graphed a rational oblique function. Congratulations.